This is the origin of the atomic theory presented to you by Anya Oshkai. People developed the atomic theory by going off the information that other scientists and innovators discovered before us. Therefore, the quote, "If I can see further, it is because I stand on the shoulders of giants," can connect well to the development of the atomic theory. This quote was said by Sir Isaac Newton. First, let's talk about Democritus. He was an ancient Greek philosopher who lived around 460 to 370 BCE and is often credited with the first theory of the atom. His atomic model said that all matter is made out of small indivisible particles called atomos, which means uncuttable in Greek. According to Democritus, these atoms were unchangeable and varied in size, shape, and weight. About 2,000 years later, John Dalton started to improve the atomic theory. Dalton categorized elements as distinct types of atoms and explained that compounds are formed when atoms from different elements join together in specific ratios. This was an important foundation for understanding chemical reactions and how different substances interact on a minuscule level. John Dalton also helped shape the way future scientists would conduct their research. He believed that science should be based on careful observation and measurable data. After him, J.J. Thomson started to improve the atomic theory. He conducted experiments using a device called a cathode ray tube. When he passed an electric current through the tube, he noticed that a stream of particles was produced. These particles were much smaller than atoms, leading him to conclude that atoms were not indivisible as previously thought. In 1897, Thomson proposed his model of the atom, often called the plum pudding model. He suggested that atoms consist of a positively charged pudding with negatively charged electrons, the plums, embedded within it. Niels Bohr is the last scientist I'm going to discuss in this video. One of Bohr's major contributions was the idea of quantized energy levels. This means that electrons can only exist in specific orbits around the nucleus, with each orbit having a unique energy level. Bohr's model helped explain why atoms emit and absorb energy in distinct amounts, which was important for the later development of quantum mechanics. Standing on the shoulders of those giants, modern scientists achieved what was considered impossible, viewing atoms using electron microscopes. The current atomic model might not be the final version yet, as new technologies are being developed. Thank you for listening.